Alright guys, hello and welcome to this new part of this exclusive Patreon series where I focus on how I created this shot for my Heroes of Bronze project. And let's have a look at how to put this guy that we made in the previous part onto 2D cards and make it into 2D particles. Because in this shot, as you well remember, in the foreground I have my 3D characters, but filling the whole scene with 3D characters is of course very taxing for the performance, and it's always best to have at least some of the characters made in form of particles. And yeah, the skill of making 3D things in Blender into 2D particles is a very valuable one. At least it was for me when creating large-scale scenes. Okay, when we have a look at our hoplite here, this bronze material is of course a bit generic because I wanted to make it as procedural as possible. So these are procedural materials for bronze and leather. That's what we made in the last part. But now, what I want to do, and of course, I have various Aspis models that you can download from this Patreon page or from my Gumroad. So if you don't want to have plain bronze on this, you can of course use some of the models that I created or that you created based, for example, on the Aspis tutorial that I published several years ago. It was actually my first tutorial on my YouTube page, I think. So yeah, it's not on the same quality level as my newest tutorials, but I think you can still follow it. If you want a different shield, you can choose another one, and a different helmet. You can download various helmet assets as well from my website or from the Gumroad page. But yeah, enough of that. Let's put this guy on a 2D plane. Alright, so first things first, I want to make the same lighting conditions that I have in my final environment. And if you remember from the first part of this series, we actually used a world shader. Let's create it here with the nodes. And I am here in the shader editor here and in the world section of it. And here into the background, I need to plug in an HDRI or HDR image, the same one that I used for the original scene. So I remember which one it was, and it was this ocean mode, this one. Yeah, so I have plugged in the very same HDRI that I used for my original scene. As a matter of fact, I remember that I've rotated negative 160 degrees, and now nothing's happening in here. That's because I have activated this preview HDRI in my scene. You need to check this to activate this. Okay, so let's in fact make our scene transparent. And this seems actually that the orientation is wrong. The sun is coming from the right, but in the final shot, it's coming from the left. I did remember correctly, it's from this side as well as on these soldiers. So yeah, let's rotate it on the other side, and this one will be better. Cool. So we have roughly the same conditions. Maybe let's make it darker. What really matters is the direction of the sun. The coloring and everything we will of course polish later in the compositing part, so don't worry about it now. And yeah, our hoplite is walking. The walking animation is cyclic. So let's bring out this timeline and see we have 82 frames of animation. So let's end the timeline at frame 82 so that we know that this is seamlessly looping. And it is. Cool. And now let's create a new camera. Let's put this camera, let's rotate it 90 degrees so that it's to the right angle of our character. Let's make this 0 and 90 as well. And push it to this side, basically so that it's viewing the soldier from the side. Let's have a look from the view of the camera. And now a very important change that we need to do is change this from perspective to orthographic. what I want to do with this step is basically just squashing the perspective deformation of this camera, because for these particles in the background, the perspective is not really that important. In fact, it would be detrimental, because if we had, some sort of camera from the top or from below, and we would have a hoplite rendered from a top view or like an opposite view from the camera, the perspective would not fit. So what I've learned is basically it's actually better to put your 2D particles, or anything that you will put on your 2D particles, into orthographic view, so that the perspective is not the issue. This way, it's not really visible whether it's from below or from the top or from the side. It's always like this without any perspective shift. And now let's make the perspective scale different here until the hoplite fits the whole screen. What's important is that you position your camera so that the bottom of his feet is at the bottom of the frame, like this. Let's see. Cool. And of course, we want to make our particle square. So let's change the resolution here, 1920. Oh, yeah, we should have done that before we repositioned the camera, but it doesn't really actually matter. Let's change the orthographic scale again and position him roughly on the middle of the frame. And now he's walking in the middle. Let's have a look at it from the rendered view. Yeah, so with this, we are basically ready for rendering our hoplite in 3 different passes. We will render the beauty pass, then we will render the normal map, which will be very important, and we will also render a specular or gloss map, which will give some glints to our soldier when he will be on a 2D particle. So yeah, let's do it. So as mentioned, we will be using 3 passes. One is this combined. You can actually preview the passes here in the EV rendering mode. The next one will be this specular light. It's basically the gloss pass. And finally, the normal. But we will not be rendering this type of normal from EV. Rather, let me jump into the shaded view and preview this matcap here called normal matcap, or check normal plus Y. This one is a little bit strange. That's because we need to remove the outline and change it to object. And from this is very important for your normals to appear properly. You need to change this here, so never forget that. Okay, and in here we have a perfect normal displayed directly in your viewport, which is super handy for very quick rendering of normals from your objects. So cool. Now let's switch to the preview again, combined, and it will be as easy as rendering 82 frames on a destination on your disk. So basically, let me just find a location. I have a special folder here, army folder, render walking, and I name these folders army underscore walking soldier underscore no underscore 9. It appears because I've rendered 8 soldiers previously, so this will be the 9th one. And yeah, I can copy the name here, paste it here, and hit underscore. So this is the naming for my image sequence that we will be rendering out. And behind this underscore, there will be the number of the frame. So 001, 002. And from this, a sequence of images will be formed later. I'll show you how to plug everything together in the second part of this video, of course. So this is my naming convention for these. And if you want, you can basically now render this whole thing just by hitting render animation. I recommend rendering in shaded mode because, you know, every time you are in the preview mode, your rendering speeds will slow down a little bit. So always switch to shaded mode before you hit final render. Let's check some options here. Let's activate motion blur actually, because it will give a bit more believability to your render. Let's also check the transparency here, don't forget that. And with that, I think we are ready for rendering. We can have a look into the compositor, and we will use it later if you basically want to render more passes at once. But let's now hit the render option and see what happens. See, it's rendering almost real time, which is awesome because we're using Eevee. If you were using cycles, it would of course be a little slower than this. But yeah, this is very fast. And once that's done, I have opened this sequence in the DJU player, which is, I think it's free, and it previews your image sequences. And let's have a look. Yeah, he's walking and he's in 2D. Let's in fact make it looped so that we check out whether it's seamless. It seems it's almost seamless. Maybe there's one frame extra. Let's have a look if we cut it at frame 81, whether it will be more seamless. And yes, it seems that we only need 81 frames, not the last 82, because that one would be doubled. So yeah, it's as easy as going into your sequence that you rendered out on your disk, looking for the extra 82 frame and deleting it. And now in the project, we will actually cut the length of the project to 81. One thing I didn't mention, I'm rendering at 50% resolution, which gives us, divided by 2, 960. Maybe it's too much, because our particles, the smaller they will be, the better for us, because it will raise the performance. So I actually recommend rendering sizes like this, or even 256 if you're doing a very wide shot with a very large army. The smaller the resolution of your final particle will be, the faster the performance when you later use it. So yeah, one thing, since we will be re-rendering this guy anyway, I want to show you how to use Compositor to render more passes at once. So let's jump into Eevee rendering, and here we are in the combined render pass, but we also want the specular light, you know, just to brighten up these things that are metallic. So let's render both these at once. So here you can see that in our compositor we have these two nodes. The render layers shows you which passes on your render layer are active and what happens with them. So when the render is when the image is actually rendered, it goes to the composite, and once it's composited, it saves on your disk in this output folder that we basically put in here. This fact that once the image is rendered, goes to composite and then gets saved is controlled here, because once you have this pipeline compositing checked, it will always save the composite output into this folder here. If you don't want it to happen, you can just uncheck it. Anyways, we will leave it like that. We only need one extra pass, and that's that specular light as an extra in here. So let me go to passes here and check this one, specular light, and you can see it actually doesn't say specular light here, but gloss directional. So that's a different name for this specular light pass. And now if we started rendering this, yeah, we would basically just save this base image, and the gloss directional would not be saved. For that, we need to add one more file output node and plug it into the image. And basically this node is telling Blender, okay, once this gloss directional is rendered, save it on this location on your disk. As a matter of fact, this location is now the same as is for the combined pass. So we need to specify a different one. Or rather, let's actually put everything that is part of this Soldier 09 into one folder. Just delete this name here. And yeah, this is actually something that bugged me for a very long time. Basically, when you specify your output in here and add a name here, your image sequence will render with that name plus the number of the frame. But when you do it in this compositor and put a name here in the file output node, it will actually not name your sequence accordingly. It will only create a new folder with the name that you put here. So to go around that, you need to go to the properties of this node here. And here, this file subpath is the naming of your sequence. So yeah, we have this folder, Soldiers 09 specified. And in this folder, it will create this army walking Soldier 09 underscore, and now let's name it gloss underscore. So two things will happen. First, into this folder with Soldier 09, our combined pass will be saved, plus the gloss directional with this naming underscore gloss. Let's in fact see if it really happens. Let's render it. Alright, now that I've rendered all the 81 frames of this soldier walking, let's have a look at the folder. And we have this combined pass here, but see, we also have this gloss pass rendered at the very same time and saved on our disk. So that's how I at least use this compositor to save more passes, more image sequence passes onto my disk with one render. This normal pass actually we will save in a different way. So yeah, we will capture it directly from the viewport here. And for that, we again need to basically rename this output. First things first, there is this option to viewport render animation, basically that captures the whole length of your timeline directly from this viewport here. So whatever we see in the shaded mode will be captured with this option. Since we have this matcap here activated, if we had the studio light or different matcap like this, it would capture this look. But let's change to that normal one. And once again, I recommend turning off anything from here because that changes the look of your normal. So make sure that everything here is unchecked and switch from material to object. That gives you the proper normal display. And now it will not take into account whatever we've set up here in the compositor. It will basically just render your viewport animation into the output folder that you specified here. So we have specified the folder with Soldier 09, and here let's just add underscore normal underscore at the end of this, and just hit render. And yeah, it rendered our normal. And if I have a look at the folder where my soldier was rendered, let's reopen it, and here it is. And you can see we have rendered our normal pass successfully. So that's the three passes I generally use for my 3D soldiers turned into 2D particles: the normal, the gloss, and the beauty, or combined, or whatever you want to call it. So yeah, let's now put everything together onto a 2D particle. So by far the easiest way is to bring the particle in by using this import images as planes option. If you don't have it, I think it's a add-on, images as planes. Yes. So it's built into Blender. You just have to activate it here and then save your preferences. And with that, in this import option, you will have images as planes. So let's just click it and find the Soldier 09 folder. And here let's scroll down to where we have the MultiPass. Find frame 1, and there are some options here. You can check presets, but there are no presets. You can make one, but what I use is animate image sequences. This should find out how long this sequence is and automatically plug it in. Use alpha straight, yeah, and yeah, this all seems good. So with these settings, just hit import images as planes. Now we need to deactivate this matcap, of course. And in fact, we can now put this plane onto a new collection, call it Hoplite 2D. And I've put my 3D Hoplite into a collection called Hoplite 3D. Okay, so I've hidden this Hoplite 3D, and let's have a look. I have this particle on a 2D plane in my scene here. Let's switch to render mode. And you can see already something's happening. So yeah, this looks cool. Let's switch to shader editor and object mode. And you can see, well, this setup that we chose for the images as planes did not actually detect the image sequence that we rendered out. It only plugged in this single image. So immediately we can change that. So switch to image sequence here, type in that it has 81 frames, or yeah, it depends on the number of frames you have. And important, check cyclic, so that it can, cycle through them and repeat every time it hits the end. Also, check this auto refresh. Sometimes it doesn't display the animation in the viewport. Cool. So that's what we have here. And this particle is now lit by our scene, changing the look of it. But I actually want to retain the lighting of the render. So the way I do it, I'm not sure it's the most precise way to go about this, but I like to plug in my soldier here, its color, into emission channel. So with shift and right mouse button, I created this point here, and you can use this reroute to plug this into emission. See, now this lighting is retained from the render, and the particle is actually not lit by the scene, but it provides lighting for its own, basically. You can bring down the specular, or rather, let's actually plug in a second sequence into the specular. It will be that gloss. And close this, open our folder where the gloss sequence is, and this time we can actually shift select all of our frames for the gloss and open image, and see, it automatically this time created this image sequence for us. So that's good. Only we need to change it to non-color and plug it into specular. So this looks good. I'm putting a new shader editor here, and if we unplug this specular and rotate our lighting, you can see the lighting is pretty flat on our particle. But if we plug in the gloss into the specular and rotate it, it gets a little more plastic. And in fact, let's see, we can in fact make this a little more contrasty. Let's preview. Let's put a RGB curves node after our gloss pass and preview the RGB curves node with Ctrl-Shift clicking on it, and put a little contrast curve on it so that the legs are actually darker, but the shield and everything is a bit brighter. Something like this. And now when we preview it, and we can actually make sure that it's using the black and white color for this. So put RGB to black and white, and let's rotate our lighting and see, now only the shield and the other bronze parts are reacting to the light. It's a small effect, but this way only the bronze parts will be glinting in the final render. And finally, we have the normal map, and that one will do a lot for this particle. So Ctrl+Shift+D, duplicate this sequence, open the folder and find the normal sequence here. So frame 1, shift select, frame 81, and with all these selected for the normal pass, open image, and it created this particle. Set it to non-color, and now bring in normal map node. Plug this into color and normal into normal socket. And let's see, you can crank up the effect of this. And now let's rotate the lighting. Actually, let me bring down the strength of this a little lower, the strength of the world lighting here. And let's actually bring in a light sun lamp into the scene to see a little bit more effect in here. Let's crank up the intensity of the sun lamp, and let's rotate it on global Z. See? There's a lot of plasticity to this particle, even though it's just 2D. Yeah. And you can, in fact, crank up the intensity of the normal map even more, like 8. And now when you rotate the sun lamp, see how the light is bending on the surface of your particle. This is actually a very nice way to add plasticity to 2D things. And as I said, you can use this workflow for trees. I actually do it in my Master 3D Environments in Blender course. I use this workflow to render out 3D trees into 2D particles and fill my whole large-scale scenes with them. This saves a lot of performance, but gives you semi-plastic, semi-3D particles on planes. So that's very cool. And this is how I made one particle to fill my scene with. It looks a little bit, it looks a little bit messy here, but to just recap, I used the base color or the MultiPass or whatever you want to call it with this frame set, cyclic and auto refresh in RGB mode, and I plugged it into the base color and the emission channel so that the light of the particle is retained. Next, I used gloss pass. I made it a little more contrasty. And I drove it into the specular. And finally, I used this normal map. Again, a sequence in non-color data mode. I plugged it into the normal map node with strength of 8, and I plugged it into the normal. And let's see how it looks without it and with it. Quite a bit of difference, I'd say. When we rotate the sun lamp, you can see the plasticity is gone, but when we plug in the normal back into it and rotate it, see how much more plastic this looks? Very cool. So that's just one particle that I created from my 3D soldiers, and I made 8 more variations. And now I've brought in the remaining 8 particles that I talked about, and they are all of them walking, and they seem a little plastic. Of course, this one is more glinty or specular because I use just a plain bronze variation of this material. But if you use more particles, there will be more variation to your roughness and specularity, and there will be more glints. So yeah, this one looks a little bit more plain than the others with all these textures here, but the workflow was the same. And yeah, with these 8 soldiers, I was able to fill my final scene with a particle simulation of soldiers walking on 2D planes. And we will have a look at that in the next part of this series.